Welcome to this screencast on developing with the Microsoft Graph. Let me first talk a little bit about what this screencast is and what you can expect from it before we start diving into the content. This screencast is going to accompany a hands-on lab and a training module that you can take advantage of that goes along with everything you're going to find in this screencast. Specifically, you're going to find in this screencast is really going to be an example of someone presenting the content from the training module as a way for you to learn how you could use this module and delivering it to a different user group or at a conference. However, you can also use it as self-paced learning. Now, the way that this module is set up is that it's broken up into a series of a couple different sections. We'll go through each one of them in just a few minutes. Each one of these sections is going to finish with a demonstration. Now, the demonstration, we don't walk through the entire step of creating the application or walking through the steps of writing all the code. Instead, we look at the final solution that has already been built and kind of pick through the code and pick through the important parts that you should take advantage of or you need to take note of. And we'll see it working as well. If you want to go through and you want to build the application, you want to see how it's being built, then what we would recommend that you do is go check out the hands-on lab that accompanies this module. Because the hands-on lab, each of the exercises maps to one of the demos inside of this screencast that you're going to see. So if you want to see how to build it and you want to walk through the steps, you can walk through the hands-on lab exercise that accompanies this module and get to the exact same place that we're showing you here in the screencast. Instead, we're not going to show in the screencast all the individual steps of creating the application. And part of that is because things change on a rapid cadence, and the lab is going to have the most updated steps and dependencies and stuff that you're going to need. The screencast is more or less showing you how the thing works or how the final solution works. So that's how you can learn more about taking advantage of this content and how we've structured this. Let's go ahead and dive into the actual module itself. In this section, we're going to talk about authentication with the Microsoft Graph, but really the authentication that we're going to talk about is really related to just OAuth 2 and Azure AD. The Microsoft Graph just takes a dependency on this. So we're going to focus just on like the OAuth 2 basics and Azure AD here. So specifically in this section, we're going to talk about the OAuth basics, different endpoint versions that we have in Azure AD, the key improvements that we have in the V2 endpoint, and then we're going to talk about a couple different kinds of tokens, like the JWT tokens and the ID tokens. We're also going to look at different types of flows and then how to obtain a token and connect with the Microsoft Graph. And the application then, in the top left corner, will be able to take that authorization code and then go log into Azure AD and provide it this code and say, I need an access token for this user. Azure AD is going to look at that code and say, I can tell that this is a code that I created, I being Azure AD, because it was digitally signed by Azure AD with their private key. So they know that the contents of the code are valid because it has a digital signature that matches one that only Azure AD could have signed. So it trusts that service. So it will then take that code. It knows that in that code it says things like it was the user was me. They're trying to access the Microsoft Graph, and that it's coming from this application, this native app. So Azure AD will look inside of its database and say, has this user granted this application permissions to the Microsoft Graph? And the answer is yes, because that's what we just did. It will then create an OAuth access token, and it will hand that back in that diagonal line going from the bottom left to the top right that says issue token. It will send that over to back to the native application. And that access token will contain the user. It will contain the resource that the token is valid for, in our case, the Microsoft Graph. And it will contain all of the scopes or permissions that the user granted the application. And now, from the top left corner, the native app can then request make an access data request over to the Microsoft Graph. That's the horizontal line across the top going from left to right to the resource server, the Microsoft Graph. The Microsoft Graph will get that token, it will look at the token, and it will say, is this token valid? It knows it's valid because it's going to look at the digital signature, and it knows that it's going to be able to match the digital signature against the public key that Azure AD uses, because the only thing that's going to match is the private key that Azure AD uses. So Microsoft Graph can say, I trust that this access token was created by Azure AD and the application's giving it to me. It's then going to open up that access token and know that I can see that this is a request for this specific user. This access token is intended for the Microsoft Graph, and it has these permissions. So it will then access the data that's being requested and then hand that back to our native OAuth client, our native application. And that's how the whole authentication dance and authentication flow is going to work here. You notice here that both the client and the resource server need to know about the authorization server, which in our case is Azure AD. Let me talk a little bit about different endpoint versions that we have in Azure AD. We have a V1 endpoint and a V2 endpoint. V1 came first, obviously. V2 came second. Now, how did this work? Well, in the V1 endpoint, there was two characteristics to it that are worth noting here, and why we don't use it in a scenario for the Microsoft Graph anymore. One of the scenarios is that Azure AD only supported, in the V1 endpoint, only supported the Azure Active Directory authentication. It did not support any other styles of authentication. And so what that meant is that if the user was logging in with a personal account or consumer account, also known as a Microsoft account, and they wanted to access things like their OneDrive consumer account or their Outlook.com account, things like that, our application would have to know what kind of account they were signing in with, and we would have to send them to a whole different authentication model. So that's one downside, because Azure AD or the V1 endpoint only supported work and school accounts or accounts with that leveraged Azure AD. The other challenge that we had is that with a V1 endpoint, it required what's called static consent, which meant that every single permission that our application was going to need when the user first logged in, they were going to have to grant all the permissions up front at that time. They had to declare everything at the very first time. But what that's going to allow us to do then is that we don't have to worry about that extra complexity. We're going to let Azure AD figure all that out for us. So that's one nice thing. That's the first 2 points. Converged authentication accepts sign-in for both Microsoft personal accounts and Azure AD Work and School, and it enables the same code, the code that we write, for using the Microsoft Graph for things like reading mail and retrieving contacts. Now, the next thing that's really important here is the dynamic consent. And what's nice about this differs from V1, where we had static consent, where now every time you go to request a access token from Azure AD, you specify the permissions that you need for that access token. Now, let's say, for example, in the example I gave a minute ago, when the user went to log in, they had to grant all permissions that this application could possibly need up front. Well, now, when the user signs in, all I really need to do is I just need to request the user impersonation scope, and that's going to allow me to get information about the current user, just get their name, their email address, etc. And now they get a much better experience when they log into my app. Maybe they're only going to use the capability to reorganize their email into different folders. When they go to do that, I can request another access token that says I need mail.read and mail.write. And when I do that, then the user is only going to be prompted for those permissions if they had not already granted those permissions to the app. The next time they go to use the app, same thing. It's going to go check to see, we need these permissions. Azure AD says, I can tell this user has already granted those permissions, so we don't need to go through that whole process a second time. But we don't have to request permissions for their calendar, for their tasks, or for their files in OneDrive. We only need to ask for that stuff when they actually need it. So I think that's a better experience because your users aren't hit with a lot of stuff. And you've seen a similar model with this, like on your mobile devices. An application may, like if you were going to use one of these social apps and you wanted to post something to this social network, let's say you just want to post some text. Well, it doesn't need a permission for that. But then if you wanted to, say, post a picture that you had taken, they need access to your photos on your phone. And so it prompts you for, do you grant this application access to your photos? Yes or no. The next thing is maybe I want to take a picture and have it send right away. So then it's going to ask for permissions to your camera. Or you want to do a little video. So now it wants permissions to your camera and your microphone. If you had installed the app and the first time you went to log in, it says, I need access to your microphone and your camera and your photos, you may be a bit turned off by the app and say, I don't want to give you all those permissions. I just want to post some text to this social network. That's what dynamic consent is all about. It allows you to incrementally just grant these permissions. And you can learn more about the v2 endpoint if you go to aka.ms/aadv2. Now let me talk about some of the other improvements from the v1 endpoint to the v2 endpoint. In the v1 endpoint, you had to provide a resource parameter to identify which resources you were requesting an access token for. And the challenge with this is that some of the open source libraries were not able to easily incorporate that into their requests. So now we use the scope parameter, which is supported by all the libraries to compound and combine both the resource and the permission. When you build applications with Azure AD v1, you also had to register all the permissions the application needed. That was called static consent. We just went through that a minute ago. The user had to consent to all of those things statically, but with v2, we can now send scopes that you want at the time you want them. We don't have to ask for them all up front. That's the dynamic consent. We're also going to change the contents of the ID token. This is the token that is going to be included with the response for the login that contains information about the current user, like their email address and their name, etc. And this is going to better conform to the OpenID Connect v1 specification. For example, we're using things like preferred username claim instead of a claim called UPN. And also in the past, if you needed a client application or a single page application or a web app or a web API or a daemon service, we had to create multiple Azure AD registrations and wire up each of the relationships between each one of those. And it was a bit of a pain. But now in the v2, this now is going to enable us just one app registration across a single logical application. And we can then open up all the different areas that we support for the different applications, such as representing a native and a web application if we wanted to. For more information, you can use that link at the bottom of the slide to learn more about the v1 versus v2 key improvement. Now, there are two primary endpoints for the v2 authorization and authentication endpoint: authorize and token. Each of these can be scoped based on the tenant section of the URL. Now, you can use either a friendly domain name of the Azure AD tenant or the tenant's GUID identifier can be used. So that's what I'm talking about at the very bottom of this table. So if you use something like says contoso.microsoft.com and you would put that in that curly bracket tenant section right there, you could use that, or you could use a GUID in that location. Now what that does is that says that your application is only going to support authentication from a specific tenant. And that's great if you're building an application that should only be used inside of your organization. Now, there's still a setting that you can put inside the app when you create the app that says that this is only what you want to support. But by using the URL here, it's just an extra capability that you can restrict it to. If you use the word common in the place of where you have the curly bracket tenant right there, what that does is that's effectively telling Azure AD, says anybody can sign in, but Azure AD, you figure out where the person is. Are they in a Microsoft account or are they in a work and school account, such as an Azure Active Directory? And if they're in a work and school account, figure out what tenant they're actually coming from. If you use the word organizations there, then that's only going to allow users with an Azure AD account or a work and school account to sign in. And conversely, if you use the word consumers, that's only going to allow users with a Microsoft account to sign into this application. Now let's talk a little bit about this authorize endpoint. So you can learn more about this at developer.microsoft.com/graphs/docs/concepts and then /auth_v2_user. Now the response mode is going to indicate if the data should be returned in the query string or if it's going to be sent back using an HTTP post. Now, what you're going to see in what you see here is we're using the query string. So in this authorized endpoint, let me explain what the context is here for this. So what you're going to do is you're going to be sending the user across to Azure AD from your application and saying, I need you to authorize the application for use. Now, when you do that, when you send the authorized endpoint, you're going to specify a few things. Notice that you're sending the client ID. That's the application ID in Azure AD that you want to use. The response type of code. Now, that's using a specific type of an OAuth code. We're going to talk about flows in just a minute, different OAuth flows, but what they are they're just different options or ways that we can obtain an access token from an OAuth supported service like Azure AD. In this case here, we're using the authorization code flow. The redirect URI is where should the user be redirected upon a successful authentication. And I'm going to jump ahead a bit where you see state at the bottom. That state value will always be sent when they are redirected over. Now, the reason we do that is so that somebody doesn't try and spoof your login and say, they send you to go log into your app from some other location. This way you can check to see, does the state value, does it equal what you gave the user when they went to go log in? It's nothing special to the user. This can be anything that you want it to be. Now, how do they get sent back over to the application? Well, that's the response mode. Should they be sent using just a standard query, which when you say mode query, that's effectively just doing an HTTP GET, and it's going to include the authorization code in the URL and the state value in the URL. But if you use the option form post, then it will do an HTTP post back to you with the value inside of an encoded payload. The scope option there, this is a space-separated list of all the permissions that you want access to when the user goes to authenticate. So this is a space-separated list of all the permissions, and it may also include a ID scope, an open ID scope for an ID token, key improvements. Now let me talk a little bit about working with the different SDKs when it comes to Azure AD. Now the nice thing about this is that you really are going to self-select yourself into which one you're going to use. If you're using the V1 authentication endpoint, you have to use the Azure Active Directory Authentication Library, or ADAL. It only works with V1. If you're going to be using the V2 endpoint with the dynamic consent and some of the other things we've talked about, which is the recommendation from the Microsoft Graph team, you're going to be using the Microsoft Authentication Library. This targets the V2 endpoint. It's got a new conceptual model of two different kinds of applications. One's called a public client app and one's called a confidential client app. A confidential client is one that has runs in a web experience where you can put both the client ID and the secret in the application. Where a public client application is one going to be more like a native app where I'm not going to be able to provide the secret. I'm only going to be providing the client ID. We also have a couple different platforms on where this is supported. There's MSAL.net for .NET Client, Windows Store, ASP or .NET Core, Android, iOS, Xamarin, Universal Windows platform. There's a JavaScript implementation, an Objective-C implementation for iOS and macOS, and an Android implementation as well. Now let's talk a little bit about this thing called a JWT token. The JWT token, also referred to or spelled out, or the way you say it is JWT token. And what it stands for is a JavaScript or a web token. What it does is it's a format of 3 separate strings that are separated by periods. So the first section is a header, second section is the payload, third is the signature. So let me just first do the signature. This is the easiest one. What the signature is this is going to take the header and the payload, and it's going to digitally sign the encoded version of the header and the payload using a private key, a secret. Now, what's nice about this is that the service that is creating the token, they're going to publish their public keys. And so what you could do is you could go obtain the public key from Azure AD, and if you know that you can decode, if the signature that you decode with the public key, if it matches the header and the payload, then you know it's valid. And the reason why you know that is because only the public key can only decode something that has been signed with the private key. And the private key is going to be held under lock and key by Azure AD. So this is a way that you can ensure that when you get this string, that it was actually created by Azure AD. And so you have a level of trust with Azure AD. All right, let's jump back. The header section, what is that? This contains a list of what kind of a token this is. In our case, it's a JWT token, but it also is going to contain the algorithm that's used to digitally sign the algorithm. So when you have like the key that's been defined, it's also going to define things like what key is being used if there's a specific key. So like in the case of Azure AD, they use multiple keys. And so what you want to do when you want to decode this, you would look at the header, you look at the key, the type of key that's being used in the algorithm, and there's a well-known URL that you go to Azure and you can say, give me a list of all of your keys, and then you can take that response, look at all of the keys that are public keys that are available, find the one that matches the one that's listed here in the header, and then use the public key in that response to compare it against the signature that I just went through a second ago. Now the payload section is going to contain a bunch of claims. This is all base 64 URL encoded. So you're going to find things that say like AUD, ISS, NBF, EXP, and app ID. So if you go to JWT.ms, you can decode one of these tokens and see what's inside of it. So AUD, what that stands for is that's going to give it the audience, and that says this token is only available for this resource. So think about it like keys in your houses. The audience for the key that I have for my house is my house, the front door at my house. The audience for your key is for your house or your apartment or whatever the key is for. You can't take your key and use it on the front door of my house or my apartment because the audience of your key is not equal to my house or my apartment. So that's how that works. That's how we can tell when I take an access token, a JWT token, and I deliver that, I hand that over to the Microsoft Graph. Well, after they validated the token, when they look at the contents of it and they look at the AUD, the audience, it can check to see, is this token even meant for me? And it's up to you to decide yes or no. Now, in the case of the Microsoft Graph, in the scenario that we're going through here, you don't need to worry about that because that's all going to be taken care of for you. In terms of the payload, so let's talk a little bit about the payload, some of the other stuff about the payload. What about the issuer? This is going to give you the ID of who issued this token. So what tenant did it come from? You could use that to check and see, is this person coming from my tenant, my organization? Or maybe you only want to accept authentication from a specific tenant, or maybe just your customers. You would have a list of all of their Azure AD directories and you could whitelist those. NBF, that says that this access code is only good, or access token, it's only valid from a specific date time. And then EXP says it's only valid until this time. So you have a nice little window when it's available. The app ID is also a list of the ID of the application. It says I'm only going to allow this application access to, I'm only going to accept the access token for this specific application. So you can see there's lots of stuff that we can do with this access code. Now, there are multiple kinds of tokens that we can use. I kept using the word access token in the last slide, but what I really mean by that is they were all JWT tokens. These JWT tokens can be used in different ways. So we can use them as ID tokens, as access tokens, or as refresh tokens. They're all JWT tokens or JWT tokens. The format and the content of the tokens is going to depend on what the different formats are. So for an ID token, these are going to be consistent for Microsoft accounts as well as with work and school accounts in Azure AD. These are typically used with the OpenID Connect protocol, and it's going to contain all the claims that you would use to sign in the user to the app. So maybe their email address and their name, stuff like that. Access tokens are requests to include metadata such as additional data in the payload, such as like the scopes. What permissions does this access code or this access token include? So like mail.read or mail.write. You really should avoid the need to parse it when you're using something like the Microsoft Graph. You don't need to worry about this. Let the Microsoft Graph deal with everything with the access token. The V2 endpoint is also going to return metadata, including the expiration and the scopes for the access token. Resource tokens are also multi-resource. Now this is really cool. What this means is that a refresh token that's received in a token request for one resource could be redeemed for an access token to a completely different resource. And you may think that that's a little insecure, but when you think about it, really what it is it's just saying that the user doesn't have to log in again to get an access token to call a different endpoint. They can use that same refresh token and an existing access token to get access to it, because the access token, like think about an example here. Let's say I was going to use I needed an access token to talk to SharePoint, and then I also needed one to talk to the graph. Well, in both cases, I'm going to have to authenticate. So once I've authenticated to the graph and I obtain an access token and a refresh token, I could take that access token in conjunction with the refresh token and go back to Azure AD and say, hey, can you give me one for SharePoint as well, without prompting the user to log in again. Azure AD already knows the user's logged in. It's already been validated. We already have an access token that proves that. Azure AD knows the access token's valid because he signed it, so he can decode it. So there's no need to ask them to authenticate again. Now, maybe they don't have permission, or they haven't granted the app permission access to SharePoint just yet. Well, that's going to kick in the whole common consent framework that may require them to go back through and consent to the application. And we'll talk about that part of it in a minute. So how do you go about creating an application in Azure AD? Well, you're first going to register an application inside of the Azure AD admin portal. And when you do that, that's going to generate an app ID. So you see that listed here on the slide. Creating an application secret is required because it's also a web URL. In the case of the Graph Client SDK, this is going to be what we call a confidential client, which is one that contains a secret. In this case here, we're not seeing that on the screen. But the client secret, that would be required in the case of like a website, because it's going to be calling back to a web URL. For example, like in an ASP.NET application, it's going to be reaching over to Azure AD from server side, and the app needs to be able to register into Azure AD. There are other kinds of applications where we would not use a secret, such as native apps. That would be like on a mobile experience or on a desktop. The reason why we don't use a secret in those cases is because we're going to be distributing code, and we don't want to distribute our secret in our code because, well, once it's been distributed, it's no longer a secret. So let's talk about how do we authorize an end user. Now, we talked a little bit about what this looked like a few minutes ago when we talked about the authorization endpoint. The authorization endpoint is going to prompt the user to sign in, and then once they've signed in, they're going to have to grant consent to the requested permissions. And you see that in that screenshot there on the slide. Once they have then accepted those permissions that are being requested. So like in this case here, we see that the scope is for offline access, for OpenID, for profile, and for user.read. So those are the 4 permissions, and you see all 4 of those listed on the right-hand side. Once they've gone through and they have accepted that, what's going to happen then is it's going to redirect the user over to the redirect URL. But notice that I have the code is listed there in that in the query string. That's because at the top, you saw the response type was equal to code. So that is a authorization code that then the web app can use to call back to the token endpoint with Azure AD and ask for an access and a refresh token. Now, a common mistake developers make is that when the redirect URL doesn't exactly match the one of the redirect URLs that are configured for the Azure AD app, it's going to have an error. So for example, let's say, for instance, if there's a trailing slash or not. If I don't include that trailing slash, well, I would get an error. So once I've got an authorization and I've obtained that authorization code or that we looked at just a minute ago, the next thing is to get an access token. So how do we do that? So you're going to issue a request to the token endpoint. You see that on the first line. You're doing that with an HTTP post. Now, when you do this, you're going to be submitting a whole string of information here. So if you look at that body that's being submitted, where it starts with client ID, there's a lot of stuff that's in there. What you're going to include is the ID of the app and the secret. So you see here we've got the client ID is equal to 50D65, etc. And then the client secret is some sort of a secret that's been defined. You see the permissions that we're requesting a token for. In this case here, offline access, OpenID, profile, and user.read. Now, if the user does not have has not granted those permissions, then Azure AD is going to prompt the user to grant it those permissions. So what you have to also tell it what kind of a grant type are we doing. And in this case, I'm saying I'm using an authorization code. When you pass that in, you also pass in the code parameter that we obtained in the previous step when we did the authorization endpoint. And then I say, hey, once you've done that, I want you to redirect me back to this URL. So the response I get back, you can see there at the very bottom. I'm getting a token back. You see it's a bearer token. It's going to list out all of the scopes. Now in this case here, you see it just says user.read. That's because the access token is only going to be for the user.read, where those other tokens like the offline access, OpenID, profile, Those are for different tokens, like the ID token. Here we can see that it's going to tell me when does the token expire. It's also going to give me a property of the access token, a property for the refresh token, and a property for the ID token. And each one of those are the JWT tokens that I can pull out. Now, once I have my access token, now I can call the Microsoft Graph. So the access token is going to be used as the value for the authorization header in the GET request to the Microsoft Graph that you see there at the very top. Some data, such as HTTP headers, have been omitted from this slide here just to make things a little bit simpler. But you can see that I'm adding in that authorization header, and then I can make my request, and you can see I'm getting my data back from the Microsoft Graph. Now, we're going to look at a demo on how to do this. And we're going to do this, we're going to simulate and do most of this stuff by hand as much as we can and not use any libraries. What we're going to do is we're going to use PowerShell to issue the request. So we're going to do, PowerShell is going to first we're going to use a PowerShell script that we're going to provide that is first going to create the URL that then the user has to copy and paste in the browser because they have to do an interactive login. Once they've logged in, they're going to get a authorization code back. So once you get that authorization code, you're going to go back to PowerShell, paste it into the PowerShell interface, and then it's going to let the script continue, which is going to issue the HTTP request to the token endpoint to obtain an access code, a refresh code, an access token, a refresh token, and an ID token. So let's see how to do all of that now. All right, in this first section, we are going to show you how to obtain tokens and connect to the Microsoft Graph using strictly just the REST API protocol. The first step is going to be to create an application in Azure AD that we're going to use to get tokens using the Microsoft Graph REST API. So I'm going to go ahead and create a new app registration, and I'm going to call this my Graph Authentication Test. And when it asks me what kind of accounts we support, I'm going to use the accounts for any directory. We can use anything right here. And I'll go ahead and say register. Now, once that's done, I'm then going to come over here to adding a redirect URI, and I'm going to specify a redirect URI of HTTPS localhost 44326. And it really doesn't matter right now. I just need to make sure that you keep track of what you're going to use. I'll go ahead and save my changes. Now, the next step I'm going to need to do is I'm going to need to create a certificate or a secret. So I'm going to come over here to certificates. I'm going to go create a new client secret, and we'll just call this my 1-year secret. And once this is created, you need to make sure that you copy this down right now, because if you don't, it'll never be shown again. So I'm going to come over here, grab this, and I'll just put this inside a notepad. And actually, now that I've done that, I should go back and also fetch the application ID, the client ID for my application as well. So let me come over here and let me keep track of that at the same time. Okay, so now we have these two things. Now the other thing we need to do is let's come back over here to our authentication piece. And what I'm going to do is I'm going to tell it that we want it to also include on the implicit grant. I'm also going to want to include the ID tokens. This is going to indicate that I want an ID token along with an access token and a refresh token. We'll see where we get this a little bit later on. So I'll do that, and then I'll go ahead and click Save. Now the next step we're going to do is I'm going to go use PowerShell to go execute a call using the REST API. So what I'm going to do is I'm going to paste in a big blob of PowerShell, big snippet of PowerShell, but we're going to walk through and explain kind of what's going on in here. So let me go ahead and create a new PowerShell document and paste this in, and let me explain what's going on here. So I've got this method here called get current user profile, and this is what we're going to pass into it. Now, when I pass this in, let me scroll down a little bit and let's see what we're looking at here. So here I'm going to be getting, for the client ID, I'm going to be getting the username, and then I'm also going to be prompting for the current password, and then I'm also going to specify a client secret. Now that's what's going to be passed in. I got my credential that I'm defining up here. And then I've also got my scopes and my redirect URI and my display tokens. Now, once I've done that, I've then going to specify the v2 URL, and I've got a bunch of other values that are being set here. So I've got scopes that are being set up. I'm going to set a code grant is what we're actually looking for, adding the app's application ID, add the redirect URI, and a couple other things as well. All right, all these different things that we're going to grab here. Essentially what this script is going to do is it's first going to create a URL to authorize the endpoint, and then it's going to, by providing the client ID, permission scopes, and the redirect URL. Now, if I attempted to use this method, invoke REST method right here to this endpoint, the result would be the HTML content of the resulting login screen. And you're going to need to log in and authorize this application. So I'm going to need to copy the URL to the browser in order to do that. So what I'm going to do here is I'm going to go ahead and run the application. So I'm going to run the script. It's like this. And then it's going to go ahead and prompt me for the username and password. Now, what this username and password is, these are the client IDs in secret that I got earlier. So let's go ahead and grab the client ID. I'll paste that in, and then I'm also going to grab the secret. Now it's going to return back a URL. So what I need to do is I need to grab this URL and paste it in the browser. So let's go grab this URL. And we'll copy this and go over to the browser and let me paste it in. Now when I paste it in, so it's going to prompt me to sign in. So let me go ahead and let me sign in. And it's going to also ask me to grant the application these permissions that it needs. So access my data and then also sign in and read my profile. So what I'm going to do is I'm going to go ahead and leave both of these options here, which I can't really do anything with them. But I'm going to go ahead and I'm just going to go ahead and click accept. Now when I do this, the browser is going to take me back to a page, the redirect URL that I defined earlier, that HTTPS localhost 44326. But there's nothing listening at that URL. That really doesn't matter, right? I'm going to go to this broken page here, and I'm expecting that to happen. What I really want is the value of the query string. I want this big code that I see here on the very end. So let me go ahead and let me copy that code out, and I'm just going to paste it over here. This code's going to be good for just a couple minutes. So what I'm going to do is I'm going to copy this code, and I'm going to go right up until the session state. So I think that's right here. I don't want session state, right? So I'll put the session state like that. Now I'm going to go take this code and I want to paste it into the PowerShell window. That was something that PowerShell was looking for. So here's the code that it's looking for. Now what this code is going to do, or what the script is going to do now, is it's going to take this code and it's going to go to Azure AD and say, I need an access token for the user that logged in for the Microsoft Graph, and I need all the scopes and permissions that this user is granted. And so this code, Azure AD knows that this code was created by Azure AD to display, it was created by Azure AD when I went and logged in, and it knows that it was for the Microsoft Graph, and I granted these different permissions. So it does that because it knows that this has been digitally signed with the private key of Azure AD. So I'm going to go ahead and paste that in and hit enter. And what that is going to do then is that's going to issue a REST call back over to the Microsoft Graph. And notice that what it's going to give us is a complete, or to the Azure AD, it's going to give us a complete Azure AD OAuth access token. It gives us a refresh token as well. And then it also gives us an ID token. And then if you look, you can see here of the result that came back. This is some of the information that came back from the ID token. This is going to give us some information about the current user. So what I want to do now is I want to go take this access token. So let me copy out this access token. And I'm going to go put this over here in Notepad again. And I'm just going to make sure that all of this is on one line. There we go. So we have everything now on one line. Now what I can do with this code is, let me go take this. If I come over here to jwt.ms and I drop this code in, and if I scroll down, you can see that this code has now been decoded. And we can see things like where it came from. We can see that we did password authentication. We see the name of the app. We can see the ID of the app, which we can tell. We could go back to our Notepad here. We can see the app that we use. So there's the BFF852. And sure enough, BFF852. We can see the name of the application or of the user that signed in. I can see all of the scopes, the permissions that were requested. So we needed an open ID, we needed a profile, we needed user.read, and we needed access to the email. There's the unique name for it, for the user. We got all that information back, right? This is pretty cool. We got all this information back just by making a simple REST API call over to Azure AD to log in. In this second section, we're going to talk about authentication and connecting with the Microsoft Graph, and I'm specifically going to talk about the protocols that we have in the V2 endpoint for Azure AD. We're going to start by looking at the authorization code grant and then look at other grants as well, like the implicit grant and the client credentials grant. These are all referred to as grants that you see on the slide. They're also referred to as OAuth flows. And then I'm also going to talk a little bit about the OpenID Connect. So let's first talk by looking at native applications. And what are these? So a native app is like a mobile or a desktop app. And these are the kind that we're not going to really use, have any kind of like a secret that we can use with our application. So what we have here are 4 different swim lanes in this sequence diagram. So on the left-hand side, you've got your app. On the far right-hand side, that's what we want to talk to. At the very bottom, you can see there, I want to get the user's information. And I want to go to the graph endpoint of /v1/me. And the whole idea here is that I need to get an access token. I need to get an access token because that's the only thing that Graph is going to respond to. Graph supports the OAuth 2 authentication protocol, and specifically it supports, or it trusts Azure AD. And so those 2 swim lanes in the middle, that's what we're going to use. That's Azure AD. And there's 2 different endpoints. There's an authorization endpoint and there's a token endpoint. So the authorization endpoint, his job is to make sure that the current user is authenticated. We know who they are and they have access to the thing that they want. The token endpoint is that now we already know who they are. Now we're going to give them a token. All right, so how does this work? So at the very beginning of an application, the application is going to send the user to the Azure AD authorization endpoint. And it's going to pass in really 2 things are important. The first thing is going to be the client ID. So what Azure AD app that has been created, what do they want to sign in with? What app is going to be granted permission? Because if you think about it, there are 3 pieces that are involved in this whole authentication dance. You've got the person that is involved in this. You've got the application, which is not just the code, but it's also the thing that we're using that is going to talk to the graph. And then you've got the graph. Well, the user has to give the app permissions to talk to the graph. And the way that we do that is we store all that information inside of Azure AD, or Azure AD stores it for us. But you have to do that by registering a new app inside of Azure AD. And so Azure AD keeps the whole app and user and endpoint. It keeps in the permissions that the user grants the app. It keeps that whole kind of combination. It keeps that in its own database. So what I need to do when the app goes to register or goes to log in, it needs to specify the client ID that it wants to connect to, or the app ID it's going to use, that we're going to grant access to the graph. The response type of code, that's just saying I want to use what's called the authorization code flow. So when I send the user over, they're going to sign in, and if they have not, I'm also going to specify that I want to make sure that this app has access to the graph. And let's just keep things simple right now. Let's just say that it just wants to connect to it. So we can have all kinds of permissions that include, but let's just say we want to connect. So the user is going to sign in, and if Azure looks in its database and says, I have no instances of where this user has granted this app permissions to the Microsoft Graph, then it goes through the consent framework. And what the consent framework does is it's going to prompt the user for the permission that it needs. All right? It's going to prompt the user for the permission that they need to grant it. And so that's where we're going to get the common consent framework, where the user is going to have to say, I accept these permissions. I delegate this app to have access to that endpoint. And once that happens, the Azure AD is going to return what's called an authorization code back to the application. Now, this code is only good for just a couple minutes. So what this code is, though, is it's also digitally signed by Azure AD. When the application gets that code, the one thing I want you to take note of here at the very top of this slide, so right in this section right here, the user has never given the application his username and password. All the authentication happened over here in Azure AD. So when Azure AD gave the authorization code back to the application, well, that's great, but it doesn't know anything about the user. And so what it does is it says, I need to take this authorization code, and I need to go to the token endpoint and say, I need an OAuth access token, and I need it for the Microsoft Graph. And so what Azure AD is going to do is Azure AD is going to take that authorization code that we passed right here. I'm telling it the grant that we're passing it is an authorization code type. It's going to use that code to look up in its database and say, first of all, do I know that this is Andrew or that whoever this user is? Do I know who this is? And then has this user granted permissions to the Microsoft Graph on behalf of this application? And so what it's going to do is when it sees that is true, and it knows that who this user is because it used the code, and that code has identified who the user is. Azure AD trusts the code because he created it. He will then create an access token and optionally a refresh token and an ID token and hand all of those back to the application. And the application is then going to store all of these tokens for later use. So let's say the first time, the application then says, all right, let's go to the graph and let's get the user's profile. So it's going to make that request to v1/me to the graph.microsoft.com endpoint and include the access token. The graph is going to look at the access token. It's going to see, as we've already gone through in this section here, it's going to see that, hey, this access token is for that user, right? It is for that app, and it has the different permissions that are in it, and it knows all that stuff about it, saying that this is valid, and it's from Azure AD, so it trusts it. So it knows that it trusts that whole component, or trusts that request, and so then it will return back the data that was requested here to the user profile. Now, let's just say about 10 hours goes by. That access token is only good for an hour. So once a couple hours have gone by, well, now it's gone. So what happens? So what's going to end up happening is that the access token is now invalid. So what the application needs to do is it needs to go get a new access token that is not expired, and it does that by reaching out to the token endpoint and says, here's a refresh token and here's my access token. This refresh token is basically a way for us to say, hey, I've already authenticated and the access token is no longer good. So I'd like to request another token that is still good without making the user log in. And if the refresh token's got a much longer lifetime, so if I'm still inside that window, then Azure AD will create a new access token and a new refresh token and a new ID token and hand all those back to the application, who he's going to then update his little store for that user and then use the new access token to go make the request. So that's how it works with the mobile and a native application. All right. So how does it work if I'm using like the Microsoft Authentication library? Well, in this case here, we're creating something called a public client, because what the public client is it means we don't have a password or a secret that we can use for our app. So here I'm defining my scopes. I've created an instance of the public client by saying .create. And then passing in the client ID. And then once that's done, I can then say, go try and obtain a access token. So I'm going to say, go try and token silently or interactively. I try and get it silently. And what that does, that's the whole process of, do I already have an access token that's not expired? If so, we'll use that. Otherwise, is it expired? Then let me try and use the refresh token to fetch a new one. And if both of those fail, so right here, those fail, and it says, hey, the Microsoft Authentication library is throwing an exception and says you need to do an interactive login, or what's a UI required exception is what's failing. Then I can say, okay, let's go do a acquire token interactively, and that's what's going to pop open the login box in Azure AD and the consent framework to obtain my refresh token, my access token, and my ID token. Okay, so what about if I'm in a JavaScript application? Well, in this case here, we've got a thing called the implicit grant. And what the implicit grant is that this is simply saying that we are not going to require you to use a secret, and everything is going to happen client side. This is good for like single page applications or JavaScript client side only applications. And when I say JavaScript client side, I mean like a React based app or an Angular app, not an app that is like built with Node.js that has a server side component. So the call to the common/OAuth/v2/authorize endpoint is going to pop up a login request and maybe a permissions consent request at the same time. But what's different about this is I don't have to go back to the token endpoint. It's going to include the access token in the request. Now, notice I'm not getting an ID token, and I'm also not getting a refresh token. At least in this case, you can say I also want to get a ID token as part of the response, but in this case, I'm just saying just give me an access token. But notice here that my response type is not set to code or authorization code. I'm saying I only want to get a token back. The rest of it all works the exact same, right? There is no refresh token, but you still are just going to be doing the login, the interactive login request. So how does that work? Well, this is all done client side. So here you can see where I'm making the request to the authorized endpoint. The response type is a token, and everything else is basically the same. Now, what about using the Microsoft Authentication library with a JavaScript app? So this is a client-side option that we have with the MSAL. And here we're creating a client application, and you can see where they've defined a login pop-up that will allow us to request, trigger the authentication process with the authorization endpoint. All right, the next part is what about a headless application or like a daemon application? And we have the client credentials grant. So how does this work? Well, what the client credentials grant or the client credentials flow, how this works is that this is a application that is like run on a scheduled basis or doesn't have any kind of an interactive user. In this case here, an admin is going to need to consent to the app, and they're going to have to do this ahead of time. So the way you're going to do that is that you're going to make a request from the application, but you're not going to go to the authorized endpoint. You're going to go to the admin consent endpoint. It's a different endpoint that you've got to go to. Once you've gone to that admin consent endpoint and the user has granted that access to it, there's no more need for this application to ever talk to have any user involvement. The application then is going to, from that point forward, is always going to use the client ID and the client secret to be able to obtain a new access token. These applications should always inspect the expiration claim of the token. So if I'm going to, like if I have an application that was not the Microsoft Graph, but it was a different one, you should always look at the EXP claim inside of your access token to make sure that the token has not expired. The Graph is already going to do that. We don't have to worry about that in this case. So here's what the code looks like if you're doing this manually using the client credentials grant. So here I'm going straight to the token endpoint to obtain an access token. And then I can do the exact same thing with the Microsoft Authentication library. But notice in this case here, we're using a confidential client. And the reason we're using a confidential client is this line right here. We can define a secret to go along with it. Once you've done that, then I can say I want to acquire a token for a client. So when you do that, when you pass in acquire a token for a client, that is saying we're doing the client credentials flow. We're not using like an interactive login or anything, or going silently with this trying to refresh tokens, because there are no refresh tokens when you have a client credentials flow and grant process. All right, let's talk a little bit about the OpenID Connect and the V2 endpoint. So in this case here, when you make a call to the authorized endpoint, it's going to pop up a login screen with a permission request for the permissions context. We've seen that before. We've talked about that already. This is how you're going to sign the user into the application. But in this case here, the app is also going to receive an ID token. All right. Now, when I get that ID token, I can use that ID token to understand some information about the end user. I can then use that ID token and pass that to the Microsoft Graph endpoint to get more information about the user instead of using an access token, just to get things like who is the user based on their name, or get their name, get their email address, and stuff like that. I don't need to validate that token, the ID token that I'm going to use for the Graph endpoint, because the application is, or the Graph is going to validate that ID token for me. I don't have to worry about that. So here's what it looks like to go make that request. You see I'm doing the authorized endpoint, and notice that the response type for this is set to the ID token right here. we can also use something called the OAuth middleware. The OAuth middleware is for ASP.NET, and what it does is it knows how to pull out the handle some of these requests or responses that are coming back to us. It knows how to pull things out to look at like the ID token. So here you can see where I'm specifying the use OpenID connect authentication, and when I do that, I'm passing in the ID, the redirect URI, the authority, and the log out URI, as well as the scope of all the different permissions that we want to get here. Now we only need to validate the ID token that's used to sign the user into the application. I don't need to validate it when it's used downstream in a downstream API, such as the Microsoft Graph. Now the last piece I'm going to talk about here is about the Microsoft Authentication library with ASP.NET MVC applications. So what you didn't see on the last slide is that we had this method here that we want to define called the authorization code received. So that's going to be triggered by the OAuth middleware. The OAuth middleware is going to have a method where he's going to be looking for the authorization code in the URL, and when he sees that code that comes back, he's going to pull that out and he can use that to go obtain an access token. And so here, what you see is I've implemented the handler for this. And what this is going to do is create the confidential client, and then it's going to use that confidential client to acquire an access token, but it's going to use the authorization code to obtain that access token. And then farther down, you can see where I'm using that by saying building another confidential client, but this time I'm specifying the client ID, the secret, and then ultimately at the very bottom, I'm able to go get that access token by saying go to the Microsoft Authentication library and using the token cache by passing in the token cache and saying go obtain the user token by fetching it by passing it in the confidential client application that way. Okay, we just went through a lot of stuff here. Let's see how we can take an existing ASP.NET application that's been configured and kind of pick through some code here where it's using the OpenID Connect middleware, and it's an OAuth middleware and OpenID Connect, and it's also using the Microsoft Authentication library to handle authentication. Now in this section, what we're going to do is we're going to look at a web application that connects to the Microsoft Graph using the OpenID Connect. And we're going to take the approach to just focus on the authentication piece and not so much about all the code we have to write. And what I've done here is I've taken this application here that is already provided, that is provided by the Azure AD team as a sample. And I just downloaded this and opened it up inside of Visual Studio 2017. Now, one of the things we're going to do is I'm going to come over here to the web config inside of this application, and I need to update the client ID and the secret. So we had created an app earlier in this screencast, and I'm just going to grab the client ID and secret for that application. So there's the ID, and then I'm going to grab the client secret, and I will paste that in as well. There we go. So we have both of those that have been set up. Now, let's go over here and let's look at the auth startup file. So if I go over to app start and we look at startup auth, this is where the authentication is going to begin to use something called the OAuth middleware. So what I want to do is what we're going to do first is we want to verify that the scope variable in the code is equal to the authentication config.basic sign-in scopes plus email. So let's go find the scope property, and I may need to change it. So here we go. So we want to point to authentication config, basic sign-in scopes, and then we want mail.read. I'm actually going to modify this as well and go get an additional one. I'm going to fetch email and mail.read. Now, when an authorization code is going to be returned, as we've already talked about that previously, what that is, when an authorization code is going to be received, we're going to call this method onAuthorizationCode has been received. So if I scroll down and take a look at that, here what we're going to do is it's going to go create an instance of our confidential client application using the Microsoft Authentication library, and then it's going to go fetch the access token or the authentication token by saying client app and then acquire token by authorization code and pass that in. It's similar to what we did in the last demo and what we did in the screencast when I showed you how we did it with PowerShell, and we first had to go log in and get that authentication code. Now, or authorization code in order to use that to exchange to get a access token. Now, Underneath the utilities, I'm going to come over here into the MSAL per user memory token right here. And notice that the token that's being persisted in a memory cache. In the case of a load balanced application, such as an Azure web app with multiple instances, you may need to centrally persist the state to avoid forcing the user to log in multiple times. Right now, we're not really doing that. We're doing this in a test environment on my local machine. Makes life a little bit easier, but it's actually be saved. Everything's going to be saved though, just in memory. And if I'm in a multi-instance or multi-tenant based application that's been load balanced, well, I could be on different servers, which means that the memory is not going to be the same across all of them. I just wanted to call that out. Now, over here in the controllers, let's take a look at the home controller, and I want to look at the about method. So let's go find the about method right here. So let's go full screen on this. Now, notice that the authorized attribute is listed here. This is going to ensure that only authenticated users can take advantage of this method. This method contains code to retrieve the current user's claims. So you can see here I'm grabbing all of the claims, or this is where it's fetching all the claims, the name claim here. And make them available via the view bag for the display by the view. The Azure AD v2 endpoint returns an ID token back to the application which contains all of these claims. And the data backing these claims is present because the OpenID Connect scopes, both OpenID and profile, were actually being requested. Now, if I go back and I look at the, in the home controller, if I look at the read mail method, so let's scroll down to read mail, send mail, here's read mail. Unlike the about method, this method is not decorated with the authorization attribute. This method is going to be using the build confidential client application that you see right here. That's a helper method that is used to construct an object that's going to implement an confidential client application. This method is then going to call the acquire token silently, or acquire token silent method, which is going to look in the cache for the token matching the user in the requested scope. And if one is not present, it's going to attempt to use a refresh token and then attach the token that requests the Microsoft Graph to retrieve all of the user's email messages. So let's go give this one a shot. So what I'm going to do is I'm going to go ahead and run the application. And this is going to be running on 44326, and that's the default. Now, if you recall, when I created this application inside of Azure AD, remember that I said I want the redirect URL to be 44326. So that's why I chose that port number, so that when the application runs, it's actually going to redirect me back over to this application. So here's our application right here. So I'm going to go ahead and in the first step, I'm going to go ahead and click the sign in with Microsoft. So this is going to take me to Azure AD and prompt me to sign in. So I'm going to go ahead and I'm going to choose the account that we've used already on this machine and plug in the password to go ahead and log in. Notice that it's asking me for a couple different permissions. And the reason why it's asking me for these permissions, or specifically the read your mail and view your basic profile, is because I haven't granted these permissions to this application. We're using dynamic consent. So what I need to do here is I'm going to go ahead and click accept, and that's going to redirect back over to my local host on 44326. And what that should do is that's going to give me back the claim. Now, if I come back, or in all the tokens we need, so if I go to the about page, again, that should show me the information for the claims that we had that was showing up. So now I can see all the information from the claim. You can see there's the name, there's my object ID, and my username as well. And I should also be able to click read mail and see the mail from my mailbox for this user. So sure enough, there's my latest email messages, and here's a big JSON response of all those different messages. So you can see back up your data in Office 365, and all that is exactly what we would expect to see. So in this demo, what you saw was we took an existing application and we that was provided by the Azure AD team, and we just configured it to use the Azure AD app that we registered in the previous demo, and we looked at the code on how it was going out and fetching all of that, all the stuff that we need in order to acquire tokens and be able to decode those tokens. In this last section, we're going to talk a little bit more about scopes and consent with the Azure AD v2 endpoint. I'm going to talk about scopes and permissions, the OpenID Connect scopes, delegated versus application permissions, graph permissions, individual user consent, admin consent, and dynamic consent. So in Azure AD and in OAuth, we call permissions scopes. They're not, you'll hear the names being synonymous, but they're really the same thing. What they are is we have different kinds of, and we also have resources. So a resource is the URL of the endpoint that we're going to talk to. So like for the graph, it's graph.microsoft.com. For the Azure AD graph, it's graph.windows.net. For the Office 365 Mail API, it's outlook.office.com. Each one of these different resources defines different permissions. So permissions can be, or again, they're also referred to as scopes. You can see them listed out here. So things like calendar.read or profile.readWrite or mail.send. Now let's also talk about OpenID Connect scopes. There are 4 different scopes that are available to us. You have OpenID, email, profile, and offline access. And they're all pretty much straightforward here. So OpenID is going to allow your application to sign the user in and receive an app-specific identifier for that user. Email, well, that's going to allow your app to access the user's primary email address via the email claim in the token. The profile, that's going to allow your app to access all the other basic information such as the name, preferred name, username, and the object ID, as well as a couple other things as well. And as far as offline access, well, that allows you to retrieve refresh tokens and silently update our different access tokens as well. Now let me talk a little bit about delegated versus application permissions. Delegated permissions are the effective permissions your app is going to have that is going to be the least privileged intersection of the delegated permissions the app has been granted via consent and the privileges of the currently signed in user. So your app is never going to have more privileges than what the current signed in user is. The app can have a bunch of permissions, the user can have a bunch of permissions, but remember that it's only the effective or the intersection of those two. Application permissions, well, those are a little bit different. The effective permissions of your app will be the full level of permissions that are implied by the permission. For example, if an app has user.readWrite.all permission, they can update the profile of every user in the organization. It does not matter what the user permissions are set to. Now, let's look at how Microsoft Graph does their permission names. You have things, the setup of resource.operation, and then if there is a constraint. So what kind of constraints do we have? So the constraints are giving us the ability to lock down specific operations. So that potentially grants the app privileges to read the profiles of all the users in directory. So like in the case of user.read.all. Maybe for shared, let's look at mail.read.share. That's going to grant privileges to read mail in the mailbox of the signed-in user as well as the mailboxes that the other users in the organization have shared with that signed-in user. What about if you have nothing listed right there? Well, like user.read. Well, that's going to grant privileges to read the profile of the signed-in user only. Or if mail.read, only read mail in the mailbox of the currently signed-in user. Now, some permissions don't require admin consent. Each individual can individually grant consent for an application, and that's what you see here. This is the common consent framework that you see listed. If the application attempts an operation that was not in the original permission request, the user did not grant the consent, and therefore an HTTP 403 is going to be returned. For example, and the scope requested is user.read. That operation is going to be requested for mail.send. Well, it's going to fail because the mail.send permission was not requested, nor was it granted. Now, there are a lot more resources. This, what you see on the screen, is just a very small example. The Azure AD Admin Center is going to allow you to specify which permissions your app is going to need. Now, this section is really only required for admin consent. This application an application can dynamically request additional permissions, so as long as the requested permission doesn't require admin consent. So in this example, we do have admin consent that's being requested. So notice that the group.read.all, that is an application permission, and it is requesting admin consent, and we can see that it has been granted for the application. Now in this case here, how do we pick the different permissions? Well, when you say I want to add a permission, you're going to see a list of all the different resources that you can pick permissions for. And then you can specify for the graph, you can specify I want to talk to the delegated permissions or the app permissions. And so in this case here, I'm choosing delegated permissions, and then I can choose the different permissions that I want. And then there's a link at the very bottom of the page that you can't see on the slide here that allows you to then go add that permission. So what happens when a user lacks permission, like is not an admin for a requested scope that needs admin consent? So some operations require admins or administrators to consent. If a non-admin tries to go to the admin consent page where it is not supported, then they're going to get an error like what you see here. It's going to tell them that, hey, you need an admin to go do the consent. So how do you get someone to the admin consent page? Well, you're going to use this special URL by going to the common endpoint /admin consent. And what that's going to allow the admin to do is to pre-consent to the permissions for all users in the organization for the specified permission. Now, it's important to note the text at the very bottom where it says, if you accept, this app will get access to the specified resources for all users in your org. No one else will be prompted to review these different permissions. So just keep that in mind. That's important. If an app requires additional permissions that require admin consent, it can direct the user to the consent URL where then an admin would then go in and consent to the application. Now we also have this concept of dynamic consent. And so in this example, you can see that the app is requesting a token for the mail.send scope, which has not yet been consented, or just trust me, it's not been consented. So the way it would work is that when you make the request for acquire token silent, which is happening in that first try block, it's going to fail. It's going to fail because the user doesn't have this permission. And so what it's going to say is that it's going to do the UI required exception part of the catch. And what that effectively does is that's going to redirect the user to an interactive login where they're going to have to request or have to go approve that additional permission that's being requested at the authorize endpoint. So let's see how all this works. I'm going to go back to a demo. We're going to take our existing application and kind of build on everything that we've just learned. Now in this last demo, we're going to walk through creating the web application or using the web application we worked with in the previous demo to connect to the Microsoft Graph using the OpenID Connect to request additional permissions. If you recall, in our last demo, we requested permissions for both accessing the user's email, reading their mail, and getting some other information about the user. But I want to go through and add this or extend it to add additional things. So if I come over here and I look in the app start /startup auth, what I'm going to want to do is when we get if you remember when I went through this earlier, when this code runs, it's going to request the scopes email and mail.read for our application. But what we're not requesting here is we're not requesting the mail.send. I'm not trying to send an email on behalf of this user. So what I want to do is if I go over here to my controller, or actually before I do that, so if right now these are the scopes that are being defined that I'm actually going to retrieve, and notice here I'm acquiring a token for mail.read. If I tried to send an email, if I tried to have some code here that was going to send an email, it would fail. And I actually have code that does that. If I come over here and I look at our home controller, inside of our home controller, I have a method here for sending mail. And here I go through and try and send a mail. Now, if I try to send this mail, this is going to fail initially. And the reason why is because I don't have permissions for mail.send. But what you see here is I'm adding in another scope. So I'm building in this confidential client again. And what this is going to do is I'm going to first try to acquire a token. Now, that's going to fail the very first time. And the reason why it's going to fail is because it's going to notice that the access token we have does not have the mail.send inside of this. And so when that fails, what I'm going to try and do is go create another request for for an access token, but this time it's going to have the scope that we just defined up here. You see my array of scopes is mail.send. I'm going to be passing that in to acquire that extra scope. This OAuth 2 request manager, this is a little utility here that we've created. So if I come over here to the utilities, So what does this do? Let's jump down to a method called, here we go. I'm looking for this method right here, generate authorization result URL. So what this method is going to do is it's going to generate the request to the authorization endpoint to request additional permissions, right? So how does this work? So I'm going through and just building up the URL here, and then I'm going to use my confidential client that's being passed in right up here to pass in, get an authorization request using these different scopes. And then I'm just going to set up some additional information here, like with the specific redirect URI, the login hint as the current user, putting some extra query parameters on here, and with the authority that we want to use. So what endpoint are we targeting? In our case, it's going to be the, I believe it's the Microsoft Graph, or the authority that we've defined on our confidential client. And then we have our execute async, which is going to go ahead and go execute it, and then we're going to wait for the response to come back. And then I'm going to get my authorization endpoint. So now what we should see with this is that when we go back to our application, so let's go ahead and let's run this again. When we go back to our application, we should see, so come over here and say sign in. I didn't have to sign out and sign in. You'll see why in just a moment. So go ahead and sign in. And this is going to redirect me back to my application. Now remember, we're only requesting access to the mail.read. We're not asking for mail.send. Mail.send is going to be requested when I go to send an email. So now, when I come over here to do a send email, what we should see, first if I go to read mail, I don't have any problem getting that because I already have that permission. But when I go to send mail, it's going to notice that we don't have the permission for mail.send. So here, if I click on this here, right here, that's going to redirect me back over to Azure AD, and it's going to go through the common consent framework again to ask me to go log in, and then it's going to prompt me to grant an additional permission for this application. So here we can say it wants to send mail as me. So I'll then go through and click accept, and now I can go send an email. So if I just send an email to anybody, like this, and go ahead and hit send, it should send an email just fine, in which it did. It went ahead and sent an email, and that email went through just fine. So now, what you saw here was how we could do dynamic consent. Even though we've already consented the application and we granted it permissions, I needed additional permissions for this one bit of functionality to work. And the way I did that was by adding in a additional permission and requesting that as a dynamic, using the dynamic consent capability using Azure AD. Now we've reached the end of this screencast for this module. You've seen a lot about how to do development with the Microsoft Graph based on the topic that we've covered here. Keep in mind that everything you saw here inside the screencast accompanies a training module where you can find slides and hands-on labs and all the final solutions that we showed you in the demos inside this screencast. So if you want to learn more, I'd recommend you check out the module associated with this screencast. Again, if you remember, the demonstrations that we showed you in this screencast, they don't walk you through every single step of building the application. Rather, we just look at the final solution that we've built and we see it running, which you can expect to see. If you want to see how to go about building a solution just like this, go look at the hands-on lab exercise that accompanies this module, because each of the demos corresponds with a specific exercise from the hands-on lab. So we have steps where you can walk through each one of these things. Again, one of the reasons we don't do all of the individual steps in the screencast is because things change on a very rapid cadence in this new cloud world, and different dependencies change, version numbers change, maybe a couple steps in screen caps are going to change as well in the hands-on lab. And so we keep the hands-on labs updated every couple months. But the videos would get out of date really quick if we tried to do that. So to save a little bit of time, we've just showed you the final solution, and we maintain the hands-on labs that you can take advantage of. I hope you got a lot out of this. There are a lot of other training modules associated with the Microsoft Graph that I'd recommend that you definitely take a look at. We've also got a couple additional links here that are at the end of the slides in the training module where you could use to learn more about this technology. So again, hope you got a lot out of this and you enjoyed this screencast. Thank you very much for taking the time to watch it.